All right, so yeah, like let's just go ahead and kick it off. What do you think, Nestor?
Yeah, let's do it.
All right. Yeah, do you wanna maybe start?
Sure. Okay. So the idea of this whole session, which was I think Clara's initiative, and she worked very hard to set this up, was to kickstart a monthly upskilling workshop, so that development. And for this first session, we're gonna cover um, some topics that are very important and fundamental. So we're covering principles and some design patterns that are bread and butter to general development. So the way that we have organized this was in two sections. So we have core principles as the first section, as the things that you would like to conceptually know to take better decisions when developing. And then you have the design patterns section, which is when you have already taken some decisions. How do you design a certain solution that adapts to the problem that you're having? So we have handpicked some design patterns and principles that we think would be very useful for this session. And also keep in mind that since the session is going to be recorded, if at some point you feel that you miss something, or you get overwhelmed, you can like rewatch this or ask questions in Slido or whatever. So um, it should it should be really fluid, let's say. So that's that's a good introduction, I think.
Yeah, yeah.
So yeah, if you want to start with your first principle, Jordan, it'd be cool.
Sure, yeah. And like one other thing to note here is that like Nestor and I will be leading this, but we know that, everyone here has lots of really great experience. And so, at any point, if you want to add any, of your own thoughts from your own experiences, please feel free. Yeah, we're definitely not claiming to know everything, but yeah, just trying to do some guided understanding and hopefully learning. So first, to kick off the core principles that we thought were most important here when thinking about design patterns for projects, the first thing is that types are necessary. So I know that a lot of developers have experience working in typeless languages, like let's say Python or JavaScript, where types are treated very loosely. But in my opinion, and I think a lot of others' opinions, is that in order to have like a really clean code layout that other people can easily understand and adapt to and extend and things like that, types become extremely necessary. Especially as you start to use some of these more complex design patterns. In order for you to properly be using them and to know that you're properly using them at compile time, types become fundamental, very, very crucial. And so if you're not familiar with the typed language, we would definitely recommend learning one. I think that if you're coming from TypeScript, or sorry, if you're coming from JavaScript, I would highly recommend TypeScript. I think that TypeScript is a great typed language because it shares, most all of the features that you would expect in a fully typed language, and it has like kind of an easy learning curve because you can write a little bit of JavaScript with your TypeScript. But ideally, at the end of the day, when you're done learning, you would be writing fully typed code, not using any types or any unknown types or anything like that. Yeah, anything to add there, Nestor?
Yes, I think that one of the key reasons why types are necessary, like in very, very practical terms, is because you will be able to detect errors and mismatching of data types at compile time and at development time. Because what usually happens in JavaScript or in Python, if you don't type it, is that you still get data mismatching errors and data type errors, but you get them at runtime. So for example, in JavaScript, it is very, very, very common to get this cannot read property X of undefined, cannot read property to string of blah, 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 and so and so. Those types of errors, which are very frustrating and very repetitive, are something that a typed language like TypeScript would greatly help you to detect them before you actually get them on runtime. And I think that you would always like the majority of your errors to pop up to you at compile time or at development time instead of runtime, especially because you want you want the errors to show to you as a developer instead of showing to a user in runtime. So I think that's another very good reason to use type languages.
Awesome. So then moving on, we have data structures. So data structures are fundamental to understanding design patterns. A big reason why is because data structures are fundamental to computer science. They are tried and true across all programming environments. And so one of the things that we have shown here is like a data structure tutorial reference that you can check out. And like you can see just like really simple data structures, like let's say stack and queue, getting into more interesting ones like linked lists and hash tables, etc. So these different data structures are the backbone of any computer science program, even if you may not think so. When you're writing in JavaScript, the interpreter of your JavaScript, the runtime of your JavaScript, it's all using proper data structures to store everything. And so these will give you a good understanding of basically design patterns in action, because each data structure that is developed, it applies a certain design pattern, some more simple than others. And so one of the great ways to learn about data structures is to not only read about how they work, but to actually try and implement them yourself. And so, it may seem kind of foreign to you of like, oh, I'm just used to using the map type from, whatever language I work in. But you can create your own map class, and you can implement the same logic that is in the map standard type that you're used to using. And so that really helps kind of unravel the black box of data structures, and I think it gives you a much deeper understanding and appreciation for, kind of like the finer nuances that, again, become the backbone to your program, become the backbone to your architectural design. And so these are extremely important, and I understand they may be tedious, but yeah, definitely recommend them because it'll level up your whole programming experience and allow you to write more efficient and optimized code. And so that's just a quick little thought on data structures. Do you have anything to add, Nestor?
No, I don't think so. Apart from there are like very good online sites where you can get like small exercises to learn from the data structures that you may not know already.
Awesome. And yeah, and instead of asking you at the end of each one, I'm just gonna kind of pause, and then I'll let you add anything that you'd like.
Alright, cool. If you want like the next two, you can ace through them, and
All right.
I'll intervene in the solid ones.
All right, really quick. So then the last two things here I wanted to add, which are kind of meta points, is that first off, the fundamentals will set you free. So for me personally, when I was in college, I really loved diving into the fundamentals. I loved learning about data structures. I loved learning about different algorithms. But once I got past that stage, I really didn't care too much. And so if you're a developer that has been working in the field for a while, but you may not have some of the formal experiences of really learning all the different data structures, really learning all the different algorithms, and you find yourself still writing a lot of code, and you want to maybe get a little better at writing your code or see how to do it better, I would really urge you to kind of go through the arduous process of learning the fundamentals. And so, to be specific, data structures and design patterns. These, to me, are the fundamentals of programmers, and it is equivalent to color mixing and brush strokes of a painter. And once you do the work of learning how to do proper color mixing and proper brush strokes, you can, feel free to paint however you'd like and be able to better express your artistic vision with what you're doing. And it's the same thing to me with programming. Once you learn the fundamentals, you can create more effortlessly and in your own unique style. And so when I'm writing code, I don't think, hey, I really should use a factory pattern here, and I should use an adapter and this pattern and this pattern. For me, it's much less formal than that. Since I already have experience working with those things, I can kind of feel out what the program flow needs, what the overall architecture needs, and I can apply that to the project in its own unique way. And that to me is like the beauty and the art behind programming, is that it's not as cut and dry. It's much more artistic than that. And in order to be artistic with it and write great code, you need to have good fundamentals, in my opinion. The last thing I wanted to add here, which is something that I think every developer should become very accustomed to doing, is just looking for in the wild examples. So what I mean by that is, looking towards other code and becoming a fan of reading other code, because you can learn so much by looking at other examples of how other people have done things, primarily in software that's widely agreed upon as the correct way of doing things. These are the references you want to look at. For example, look at how HTTP was implemented or WebSockets. Maybe look at how the DOM functions and how that works. The model view controller architecture paradigm that was very prolific. Looking at the actual source code for React or Lodash or other very, very popular JavaScript libraries, Docker containers, ASTs. The list goes on. If you see a thing in computer science, if you see a thing while you're coding that is proliferated everywhere across a ton of code, it's widely agreed upon. It's something that a ton of people are using, and so it's really worthwhile to actually go and check it out. And I guess the last thing I wanted to state here was that in each domain, there are different design requirements. So this means that those design requirements breed their own set of prolific design patterns. And so, for UI development, there's like the model view controller paradigm. There's, a hierarchy of components paradigm. In game development, there's component-based design and then also data-oriented design. Lots of other paradigms that become very prolific in different fields, in different development domains. So that is my first 4 principles. I would love for Nestor to take it away for the solid principles.
Yeah. So I think that something key that you said about the fundamentals is that when you really understand and assimilate the fundamentals and why are they fundamentals, you start to feel what would be best by instinct, as a painter would do, as a chef would do, instead of saying, oh, I'm gonna use this specific A, B, or C pattern here. And I think that's something that's very true. And this is precisely the reason why we wanted to cover a little bit of the solid principles here. So the solid principles are a group of principles that Robert C. Martin mentioned for the first time in his literature, and they're aimed towards a better software architecture solution design. So if you don't know Robert C. Martin, I highly, highly recommend his literature. He's the author of Clean Code, Clean Architecture, and Clean Craftsmanship. And I think they are like very good books. At whatever level of development you are, I think you will find like very useful information there and some like rules of thumb that you can use as you learn. And so SOLID is an acronym that stands for several different things, and each of these things, it merits its own discussion. and we could spend a whole hour talking about a single one of them. So what I would encourage you to do, as we go through them and give like a brief overview of what they mean and what should be done with your code in regards to the principle, is that you also do like your own reading, like in your own time. Try to deepen the knowledge of each one of these, because they really apply to pretty much everything in software solution design. Yeah, you wanna go the first one? Maybe the first two, Jordan, and I'll take the other three.
Yeah, for these two?
Yeah.
Sure. Yeah, so for separation of responsibilities, I think that it's important to first think about the abstraction layer that you want to be developing at. If you're building a tool chain and you're thinking about projects, like that's kind of your core abstraction layer. If you're building, let's say a backend for a database, and you want to think about, database actions, that's your first kind of abstraction layer that you want to build at. And once you figure out your abstraction layer, then you create, different classes, different functions, different modules that handle these different pieces of responsibilities. And so to talk about a quick example, let's talk about a database management service. So, we are going to be thinking about actions, and so we may have an action structure. This action structure should be, just associating itself with the action itself. It should have the data for what type of action it is and the associated data with that action that you're going to be performing. This action should not necessarily concern itself with what type of database it's being applied to. Who the caller is necessarily, and like what other actions they may be doing. In order to have clean separation of responsibilities, the action should be isolated, and it should be, its own little clean container. I think that that's kind of like the easiest way to think about it, is that, finding your abstraction layer and then building clean containerized structures and functions around those different like core pieces of your abstraction. It's kind of all I can really think about saying for that one. And then secondly, open for extension, close for modification. So this to me is extremely important if you're trying to build reusable libraries. So, what are some examples of reusable libraries? Think of any data structure that you've used, like a map or a set or, a queue. Think of any popular library you've used, like let's say React or some other library. All of these libraries, in order to extend their functionality, they typically have a built-in way for doing so. For example, it could be as simple as passing in a callback function when you read a file, or when you perform some asynchronous action, you pass in that callback function. And so this is actually a really powerful point here, because the developer of that library specifically chose to allow the user to extend its functionality without modifying the core library itself. And so there's a few different ways you can do this using design patterns, and this is what a lot of the design patterns are built around, being able to create pieces of code that are extendable, but you don't have to modify them, so they kind of remain like a solid rock inside of your code base. Yeah.
Cool. So I just wanted to say that for the open for extension and close for modification, it is very important to consider that your code should be tested. Like you should take the time to write tests for your code, not only to check if things work, but also to check how a consumer of your components, of your library, can interact with your components. And this is particularly useful not only to detect things that don't work, but also things that work but don't feel fine in terms of a consumer perspective. Um, you will understand a bit more about it when we reach the D in solid. Um, but for now, I thought that the first two are more um, general, but the last three are easier to understand if we explain them with some code snippets. So we prepared a some small snippets to explain these. So Jordan, if you could open up the the listcup file in the Explorer.
Yeah, definitely. Is it, here we go. Got it.
Yeah, there. Okay, so the listcup substitution principle, and I encourage you to do your own rating about this also, basically states that in 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 very simple terms, like a child class should be usable wherever his parent is expected. And how so? So take this example. So in math, you would consider a subtype of the rectangle, or a special case of rectangle. So so you say, oh, okay, so then rectangle is the more broad type, and square is a subtype of rectangle. So you model your abstraction in a way where square extends from rectangle. And here you're going to run into a problem, because square has height and width, and sorry, rectangle has height and width, whereas the square needs to have the same dimensions all around. So if you put square to inherit from rectangle, you're going to have some strange behavior, because as soon as you call the inherited methods from rectangle, like set width or set height, um, you're going to end up with a square that has uneven sides. So it's no longer a square. And this is what you can see here. Like if you initialize your square with 5 uh, as the size of its sides, and then you do set width, which is an inherited method, then you will have a square that has a width of 10 but a height of 5, essentially not a rectangle. Um, and and this is the perfect example to show that somewhere where you would expect a rectangle and you call multiple times set height or set width, um, you should not use you should not fit a square in there. And that simply makes you point out that the abstraction is not well done. So square shouldn't inherit from rectangle. The theory concept behind this is called strong behavioral subtyping, which is the concept that I would urge you to research about, which basically says model your classes not based on their properties, but in a way that behaviorally makes sense. So I think that would pretty much cover it. If you have any questions, like just put them on the Slido and we'll address them. I don't know if there's anything that you'd like to add there, Jordan.
Nope, not at all. I think that was really well.
Cool.
Yeah.
So then, with interface segregation, if you open up the example there, yeah, there. Okay, so basically, this principle states that no class or object should need to implement things that it does not use. So how so? Well, if we had an interface, like for example, this one, we say, oh, okay, so let's make an interface for our order. So then we put all the order types there, like order burger, order fries, order combo. And then when I create my burger order service, which is an order just of burgers, I implement the order service that I defined above. And what's going to happen is that I have 3 methods that I need to implement, but in reality, I will just use one of them. And the other 2, if called upon, should throw an error at runtime. Like, this is a bad interface planning. And the correct way to do this would be to segregate the interfaces, which means take the big interface up at the top and segregate it into smaller interfaces so that each service implements only the interface that it will work with. And I think that's it.
Yeah, definitely. And you know, as you're talking about this, I just realized like an area in my own code where I do this, and it really is like a great way to, you know, have code smell. You know, like actually see where your abstractions are not correct, and you need to further flesh them out better. Yeah. Awesome.
Cool. And then the final one, I think it's, in terms of understanding it practically, it's very simple. But then conceptually and what lies behind it is, to me, the most complex, which is dependency injection. So when I was in college, the first web framework that I was exposed to was Angular. And Angular uses dependency injection for everything. And I struggled to try to learn Angular at first because I didn't know the the core principle and understanding behind this. So to explain it in very, very simple terms, let's say that you have an Ethereum service, and you basically build this Ethereum service passing a URL. And then what this does on line 10 is basically that the Ethereum service uses the URL passed via constructor to instantiate an HTTP provider. And then that HTTP provider, it saves it as a property of its own. And then on line 13, where we have send transaction, inside of that method, the Ethereum service would use the provider that we instantiated in the constructor. So this happens all the time, and the natural instinct that I've had for years was to do exactly that, like, because it doesn't look wrong. And it's maybe not wrong per se, but it is naive. Why is it naive? Because I am essentially making my Ethereum service class dependent upon the constructor implementation of HTTP provider. So if I change my constructor signature in the HTTP provider, I would also need to change this part of the code, which is a consumer. And that violates also the open close principle. And not only that, but I think that where you're gonna feel that things are wrong is when you attempt to write a unit test for this. So how do you test that your error cases for this particular service are indeed working as they should? You would create a unit test, and then when you're gonna instantiate your service, you need to pass a URL. So you won't be able to mock the HTTP provider because you can't do that. So this code becomes very, like, much harder to test. And as it gets more harder to test, you are gonna simply avoid writing tests at all, and and uh, and then you get the feeling of, okay, so maybe I'm not doing this the right thing, the right way. So what's the right way? Dependency injection basically says that the dependencies of a class should be passed already built to its constructor or to its setter. There are several ways to do this, but the easiest to understand is passing them through the constructor. So basically, if Ethereum service depends on HTTP provider, I build the HTTP provider before, and then I pass the instance already built to the constructor. So this way, if I wanted to write a test that tests that my error cases are working fine, then it's very easy for me to mock an HTTP provider and then pass it to the constructor. And also, if my constructor implementation changes, it will not affect this code, because essentially the Ethereum service is not depending on the HTTP provider implementation anymore, but rather it's depending on its interface. And that's how it should be. Um, so this, of course, may sound counterintuitive at first. And when you do it in a production level application, you will find yourself with very big dependency chains. And that's precisely the reason why frameworks like Angular have like their own way of helping you resolve dependencies with DI. This is also something that decouples creation from behavior. So when you touch production grade applications, you usually say, hold on, so the bug is on line 30 because this object is not doing what it should. So where the hell is the object being instantiated? Like, where is it being created if it's not being created here? Because since a production grade application you're exploring uses DI, that dependency should be being declared way above in the in your class tree. I can explain more about this, but I think that's like a good introduction to it, and then we can speak more about this if there are more questions around it. Is there anything else that you'd like to say, Jordan?
Yeah, no, I think you described that really well. And I just wanted to add that, one of the other ways to make this more future-proof is to not necessarily use the whole HTTP provider interface, because this may, contain lots of different properties and methods, and you may only be using one. And so if it is the case that you are, only using, let's say, one or a few different properties or functions, it's really worthwhile to define your own interface for this.
Agreed.
And so here, like, you can just say provider, send async, as a function, which is, returns promise, let's say. And so instead of using HTTP provider here, you can just use provider. And then now you can just use the send async function. And users can still use your class like they normally would. They can still, do it with like a different provider, or they can still do the HTTP provider. And the reason again for doing this is that it is more future-proof. So if the library that HTTP provider is coming from, makes changes to some parts of their interface, your users should know what parts of that interface you require. So if you just do it like this, they have no way of knowing that you only need the send async function. So as long as that's there, it's going to work, regardless of what version this class is. And so doing it like this kind of, allows you to say, hey, I specifically just need this function. Yeah. All right, cool. And so it looks like next up we have object-oriented versus functional. And it looks like we're doing really good on time. We're 40 minutes in, and this was scheduled for an hour and 30 minutes, so we're about halfway through. And so we'll definitely be able to finish this off really quickly and then, have enough time for Q&A. So nice. So yeah, how should we talk about object-oriented versus functional? I quickly started writing up a quick example. So apologies, I wasn't more prepared for this, but basically I just wanted to give 2 quick examples of what object-oriented programming looks like and what functional programming looks like. And to me, the main difference here comes down to state management. With object-oriented programming, your state is going to be stored within the object class. When you create your new classes, you will be giving it configuration properties. These configuration properties may be used inside of, let's say, the method. Different methods you can call on this class instance. You can pass around this instance and it's going to still retain these configuration properties. And so I could, let's say have instance 2 and I could have this be, something else. And then additionally, as I was saying, like, these class instances can maintain their own state. So not only can that be done through configuration properties, but it can also be done through methods, where maybe, you could have like an increment internal counter function, and then you could do like, instance.getCounter or something like that, right? So yeah, this instance, it is stateful. And so that is kind of, to me, like the main premise of object-oriented programming. Is building instances that are stateful and can be, linked together and stuff. Now, when thinking about a functional programming approach to this, how might we build this? Well, first off, we could have a method, and then we could have, let's say, some state structure. We could create state, or let's call this configuration. And so we can have some configuration structure that could have property foo. And when you call method, just like it was happening up here, where you say instance.method and it uses foo, in a functional programming approach, since these methods are pure methods, meaning that all of the state or all of the configuration is passed in, all of the configuration plus state is passed in. And then returned is typically like a new state. And so here, like if we wanted to think about also like the increment internal counter or something like that, it would be instead renamed to increment state counter. And then you would have some notion of state. And then, you create, state. And, it's also worth noting that these design patterns can be used together. So, new state, we could be using objects here. We could pass it into increment state counter. And then we could, have new state. So, yeah, anything to add here? Yeah.
So in the way that I perceive it, is that in pure functional programming, you have more quote unquote immutability of your objects, whereas in object-oriented you play with state mutation a lot, and there are like design patterns around how to do that properly. But in functional programming, you have like lots of pure functions and object duplication. So they both have advantages and disadvantages depending on the case. But in the case of TypeScript, for example, in web development, you can certainly combine both approaches for different parts of your application pretty often.
Yep, I definitely agree. And one rule of thumb, because I think that it can be easy for people to fall into the trap of just creating too many objects. And so for me, like the rule of thumb that I use is that if I have some method on an object that is just doing something that is not stateful, it's not requiring any of the functions where it's like this.property, right? We have a constructor. So given this example, this is an example of a stateful function where it's using, the object instance's state. But this is this is a pure method. And so, what you can do to make this not a part of the instance, because you could imagine I might just want to call method, right? What you can do is you can make this its own function. So, you could just have this as its own function. Or if you want
It's static.
Yes, definitely. So another option is maybe you want this method to be associated with the foo structure still, and so you could do static. And so what this means is that you would do foo, dot method. And so it's still associated with the foo object, but you don't have to create a new instance of it to use it. Yep. Cool. All right, so that's object-oriented, functional. Avoiding globals using instances. So this one is pretty straightforward. Basically, if we look back to our object-oriented programming example here, let's just take this instance for example. So why globals are bad, generally speaking. Not always. So here we have like a new instance, and you can imagine that it would be very frustrating if when we called increment counter, and then if we then called get counter, right? This should return, effectively 1, right? And if we had, let's say, like another instance, new instance 2, and we call this, increment counter, and then we call new instance 2, this should be 1, right? Because they're both separate instances. What will happen is if you're using globals a lot, it may lead to unexpected behavior from the user, where they may be expecting you to respect instances. They may be, expecting you to not be storing any internal state within your modules, but instead, this would be returning 2. And so what exactly does this look like? Well, what it looks like is like when you're defining a new module, it just means that you would have a function, increment, and then you would have, let's say, like let counter equals 0. So this is bad. This is a global variable. Yep. So yeah, that's kind of the main point there. Okay. So the next up, we have private by default. So the main principle here is that you should only be exposing to your users the things that they care about. And so, if we have, let's say, like a class where it's like a utility class, we could have like some public utility that we want users to use, and then this may use some, like, let's say, internal function to do something. And so now what we've done, because in TypeScript these are public by default, so these are public functions by default. If we create a new utility, when I as a user go to use it, I'm now confused with what function should I be using on this utility class. You wrote your code assuming that I should never call this function as a user, that this is just for you to use inside of here, let's say. But instead, I'm now seeing it in my IntelliSense, so maybe I should use it. And so a good way to work around this is to basically make this so that you make it private. What I like to do is I like to have different naming conventions for my private function, so I put an underscore before it. This is a common practice that's used in a lot of languages, so it's familiar to programmers. And so now, as you can see, I can no longer call internal function, but I can call, when I call dot, I see that, okay, this is the function that I should call. So that's the general principle there. It's also really important to do this with data properties. So, internal, value. If you forgot to add that, the caller could just say internal value is equal to 5. And then that may mess up your whole, class. So making sure to just have things private by default and only exposing the things that they care about. And the last point here is that it not only matters for classes, but also modules. So when, let's say, we're exporting things, maybe we want to export the utility class, but maybe we had some, let's say, some helper class up here, class helper that we use. If we don't want the user of our module to know about this, then we don't have to export it. So only exporting the things that you care about, so that when people are using your library, they know what to look for and what to use. Cool. Data ownership. Was this one you or was this me, Nestor?
Which has X. Oh, is that Jordan? Yep. Oh, okay. I think if you wanna take it from here, Jordan. I was just explaining how variable scoping works, and why you would like to avoid making a variable be global, because you allow it to be accessed and manipulated by scopes that you don't intend to access your variable.
Definitely. Yeah, I was actually explaining this as well, but I didn't realize that I got DC'd. So let me share my screen then really quick, and yeah, really sorry about that. Okay, can you see my screen?
Yep.
Okay, great. So yeah, not to rehash this whole thing, but just to talk about private by default. Oh, and sorry, we didn't even do the global example. So basically, how I was describing the global example, and sorry, Nestor, if I'm going over this twice, but basically talking about why globals are bad. If you have two object instances, you may be using one object instance to increment a counter, like so, and when you get counter, you would expect it to be 1. And so now if you use the second instance and you increment a counter, you may expect this to be 1 as well. But if you're using globals in a poor way, there may be a global counter, and this could be 2. And so as you can see, this is very bad behavior from a user's perspective. And what this looks like in your code is that it looks like adding a counter to the module scope, to the global module level. And so always avoid this at all costs. There's very few instances where you actually want this, but yeah, so that's global. And then the next point that I'll just say one more time because I got DC'd, which is private by default. So private by default, what this looks like in practice is that you could imagine that you have a utility class where you could have, let's say, let's just remove this really quick. You could have some public utility function, and you could have some internal function. So let's do this. And so as a user, if I'm creating a utility class, if I do ut.internal function, as you can see, because this was not made private, I can now, see this in my IntelliSense, and I may try to use this. And so this could actually mess up the internal state of your class. And so a better way to do this is to make it private by default, and only expose the functions you want your users to use. And this doesn't just go for methods, but it also goes for properties. If you have some internal value set to 0, and you forget to put private there, as you can see, I can now set internal value to whatever I want. And this could, again, mess with the internal functionings of your class because you're not expecting outside users to modify these things. And so, just a simple way to fix it is just put private there. And then the last point on privacy is that, this doesn't just go for classes and properties, but it also goes for modules. So when we're exporting things from our module, if, let's say, we had some internal helper class, if we, just kind of like, just through habit, we just wrote export before everything, and, we're just exporting everything from our module, the users of our module would be able to, use our internal helper, and they may not know that this is something they should not care about. So instead, just to make it really easy on your users, only export the things that they should care about. It just makes using your libraries that much simpler because they only have to worry about the utility class and they don't have to care about what this is and understand why they shouldn't use it. Cool.
The design rule of thumb that I usually like to use is don't allow the consumer of your objects or components to misuse your abstraction. And the easiest way to forbid your consumers from misusing it is to, by default, don't let the consumer use anything, and then you progressively allow them only certain entry points to your component. And that way you basically say like everything for the consumer is disabled by default in terms of manipulation, and then you only allow what you explicitly want to allow. That's why I put private by default and only public like what's to be actually consumed.
Yeah, and I just wanted to add that in order for this to work well and for you to not have to rewrite your code multiple times, you need to write good test code to actually exercise the critical paths that you expect users to use. This is the only way that you'll really know if you're exposing the right things. Because it's happened to me before where I've written some code, I haven't tested it well enough, and then when I publish it, somebody contacts me and they say, hey, we really need you to expose this function in this class. And I say, oh, I had that as private because I didn't think that a user would use it, but I now totally see why that's valid. So yeah, testing is really important to make sure that this is good for users. Cool. And so then the next thing on the list is data ownership. Was this me or you, Nestor?
That was you.
Okay, cool. So I just wanted to say that data ownership in programming is really important. There can be lots of cases where you're passing stateful objects around or different data structures around, like an array or a string, and you may not know what functions or classes you're using are modifying that data. And so this is why using things like const is important. In TypeScript, there aren't strong rules. Sorry. In TypeScript, there aren't strong rules against mutability, like there are in other languages, like let's say Rust, or even in languages like C++, where const is used, I think, more efficiently. And so, it's kind of hard to make sure that your code is as kind of bulletproof as possible when it comes to this in TypeScript, but it's really worthwhile keeping in mind. And if you want to have a much better kind of understanding of the rules of thumb around this, I'd really recommend learning a language like Rust, where its core principle around its design is data ownership, where you have to explicitly say in your programming, I am giving ownership of this data structure, this array, to this function I'm calling, and it can modify my array because it now belongs to it. And so, yeah, like just lastly to finish this point off, the reasons why this is so important is because it again makes your code more bulletproof. It allows for less runtime errors, and it as well makes it easier to thread your program. You're able to actually pass data ownership over to a thread, and not have anything cross boundary. And so, yeah, data ownership is important and something to think about. Cool. And then the last thing that I added here was just multi-process and multi-device considerations. So this is something that it may not be applicable if you're thinking in just like kind of a single application context, building a web application. But as soon as you move into developing on, back-end services, thinking about building tools, you need to be thinking about your process architecture and also your device architecture. Like what devices am I talking to? And so a quick example of this is if I am writing a CLI, if I write a file for the CLI to, some folder on my system, let's say it's like, user/bin or something, some global folder. I need to I need to account for in my programming basically locking that file's use and making sure that no other CLIs that are running in parallel to my process can actually modify that file as well. So this multi-process considerations are very important when building things that touch the system, and also touch the network and stuff like that. So yeah, not much to add there, but yeah. Cool. So, Nestor, do you think that we should, we've already covered a lot of design patterns. Do you think that we should go through each one of these, or should we just jump straight into questions and just general talking?
Yeah, I think we can go straight into questions, and if somebody has like a particular interest about a particular pattern, there are like some snippets already on the repo. So I think, yeah.
Okay, awesome. Well then, yeah, let's just jump right into it. So first one on this list is, hey, this is a test question. Check how this works. Awesome, it works. Yeah, and so the next ones we have are how do L2ZK rollups work product wise. All right, let's cover this in just a second, because I could see this leading to kind of a tangential conversation.
Broad conversation.
Yeah. How do you decide on a technical stack for a project? Yeah, do you have any thoughts on this, Nestor?
Yeah, so I think that different tools are good for different things. So what I usually do is that I check like which tool is best for what, and then I take it from there. But I don't have any hard rules. And I think that sometimes when you choose a technical stack, there are like tools that would suit your needs alike, and then you take like softer things into consideration, like what do you know best, what does your team know best, and so.
I think that for me the two biggest things are, is it something that has been used and tested a ton in the space, and it's been in production. So actually using things that are production ready, so you don't have to spend your time trying to debug things in the stack that aren't working for you. And then secondly, choosing things that your team and yourself are accustomed to using, so that you can actually build what you're trying to build. It's perfectly fine to build a side project to start testing out new libraries, new tool chains, but when it comes to actually building something that's production ready and you need to move fast on, and you need to accomplish what you're trying to accomplish, then you should be using things that are very battle tested, and things that everyone can learn and use easily. Okay, so what are your thoughts on learning Rust for long term in the Web3 space? It seems that a lot of protocols use it, and that Solidity will be less useful over time. Yeah, this is really interesting. In my opinion, I think that Rust is, yes, it's definitely like the native language of the future. Rust is not gonna, modify your web development anytime soon. But for everything else that you want to build, whether it be smart contracts or backend services or system level processes, like all of that stuff is great to be written in Rust, and we've seen that happen in the Web3 space a ton. So yes, I do think that Rust is a great language to learn, and I understand that it can be intimidating, but I think that it is much easier to learn and build with safely than other languages like, let's say, C and C++. It has a lot of great language constructs and a really great compiler that make it easy to write good working code. And so yes, like Rust is something that will not only teach you a ton, but it'll open up a tremendous amount of opportunity for you in into the future. And
Yeah,
yeah.
and if you come from a language like which is very high level, like JavaScript, for example, when you start working with Rust, you're gonna be forced to become aware of lower level concepts and fundamentals. So in a way, if you come from high level languages, say Python, JavaScript, and so, uh, by learning Rust, you will also be forced to learn other interesting development in computer science concepts. So that's also really useful for your career in general, I think.
Yes, definitely. And as far as if Solidity will be less useful over time, um, I think that this can go a lot of different ways. Currently, Solidity is the standard for building, EVM-based smart contracts. And the reason is because there's such a tight coupling between the Solidity development team and the EVM development team. And so, new features that get added to Ethereum, like, new gas setting features or new hashing algorithms, they're immediately present in the Solidity language. There are other projects that are trying to create Rust compilers that, build Rust code into EVM bytecode. But these are more experimental, and they're not even at the running stage, right? Like they're still trying to crawl. And maybe in the future, if more and more development groups want to use Rust to build on EVM, this project could reach like a full production ready state, and then it could be just as up to date as Solidity is. So in that scenario, I do think that there is probability that Rust could take over as the de facto standard for building on EVM, but that is quite a ways away. Yeah. All right. Cool. Next up, if you were just starting out your Web3 career again, what would you do? What projects would you try to work on? And what would you try to learn? Yeah. Does anyone wanna take this? And like it doesn't have to be myself or Nestor, but like anyone here, if you guys have any thoughts.
Yeah, so I can give my thoughts on this one. What I would do in here, it's basically there's a lot of hackathons out there and grants, like to all kind of levels in the Web3 ecosystem, talking about developer point of view. So yeah, basically, I did this. Fun fact, I did this on the COVID quarantine like 2 years ago. I won a compound hackathon in one of these hackathons. So yeah, basically what I would try to do is to play with some projects, ideas, and like yeah, give my mind some challenge regarding code, and you can get paid for it, right? So yeah, I would say that's a good way to go. Basically, being a hunter of these hackathons, which are I have like prices for every level.
And I kind of think that contributing to libraries, it's also like a great thing. And if there are like bounties in Gitcoin, for example, around libraries contribution, that is something that I would definitely say that helps a lot, because it requires you to do your own research, learning and understanding of how things under the hood work. Because I think that if you start working right away on dApps, on the applications, you can unintentionally skip a lot of the uh, core concepts.
Yeah, I would echo both of those things. For me, when I joined the space, just a couple years ago, like, I had never built a web app, using like any web framework like React or something like that. And after doing my first hackathon, I was able to meet others who were building in the space. So that grew my network of people building in Web3. And then additionally, I was able to learn lots of new technologies. Building web apps using different Web3 frameworks like MetaMask and Web3.js, and also building on top of existing protocols. So that's kind of like my second big point here, is that you ask a really great question of what projects would you try to work on. I think that's really important, is to not start your own right away, because there is so much that has been innovated and done in the Web3 space, and now especially now, there are kind of like pillars or really set in stone bricks of the Web3 foundation, whether it be IPFS and libp2p, or whether it be Uniswap and Ethers. These are really kind of hardened projects that can teach you a ton of the fundamentals of building in Web3, that you wouldn't be able to learn easily otherwise if you just tried to set out on your own and build your own thing. So this is what we did with dOrg. We built with the DAO Stack project early on because they were, building great stuff, and it seemed like they really knew what they were doing. And so we started building in their ecosystem. And so, yeah, I think finding a big fish to, be a little fish under, look at their code, study their code, build your own stuff, and then slowly, like, you can break away and become your own big fish if you're interested in doing that. But it all starts with finding that like solid big fish to learn from, I think. Cool. All right. So then, all right. So it looks like we have two questions around like ZK rollups. So let's just talk about it. So how do L2 ZK rollups work product wise? If I mint an NFT on Starkware, is the ERC721 token gonna come up on ETH mainnet 2 at some point after the rollup? Yeah, so in general, how do L2 ZK rollups work? First I want to preface that I'm not an expert, but I do have some understanding. So with any type of layer 2 rollup, that is not just a simple side chain, like it's not just a typical blockchain, but it actually tries to, optimize the rolling up of the transactions, so that it can publish its whole state to a layer 1. What they're doing is they're creating, basically, there's this concept called a Merkle tree. So, or also it's called a Patricia tree. Basically, it is a tree data structure that uses hashes to tell you what the next nodes up are. And you can boil the whole tree state down into a single hash. This is something that we use in blockchains today, but this is kind of like a meta hash tree where it's using it with like a sub blockchain, like a layer 2, that's running beside the main blockchain. And what it does, and the reason it's called a rollup is because it takes all these transactions in the layer 2, and every so often it will, bundle them all up into, a single hash or a series of hashes, and it'll publish that to the layer 1. So let's say Ethereum mainnet. And this allows you to get great security properties, so that if somebody tries to, publish bad transactions, they can see that, okay, these bad transactions did not make it into the final state that was published to mainnet, which was agreed upon, through all of the L2 nodes. And so that's kind of what rollups are. what zero knowledge is that this is like additional math that is added on top of transactions, where you can not only create transactions in a zero knowledge kind of way, not having to expose who you are, what you're doing, but also nodes can validate the transactions without having to know what exactly is in the transaction. And so a lot of people refer to, zero knowledge proofs as, and like there's a bunch of different types, like there's snarks, starks, but yeah, people refer to these as, as moon math, because it's really cutting edge math that allows you to do things that were traditionally thought of as impossible. And this is completely changing the game for blockchain development, because you can really, really well optimize the data in which you have to transmit to the network in order to prove like what you're doing. And so this allows blockchains to scale more. And just to quickly answer the question, like, will the NFT on Starkware ever make it to ETH mainnet? That's certainly possible. Somebody could create a smart contract on mainnet that looks towards those roots that are getting published, and you could then basically ask that mainnet contract to then basically migrate your NFT over to mainnet Ethereum. And so yeah, like as with every other bridge, there needs to be smart contracts on both sides. On Starknet, you would deposit your NFT, and on mainnet, you would basically bridge over your NFT and recreate it on mainnet. But I'm not 100% familiar with the ERC 721 standard, so maybe this is not possible like it is with the ERC 20s. But yeah, that's just my initial thoughts there.
Yeah, everything you said is 100% correct, and it works the same between ERC 721 and ERC 20. It's just that the answer to this question is no. By default, this will not happen. So the ERC 721 token will just be on Starkware. It will not come up on mainnet. What comes up on mainnet is that small Merkle root, so only that hash of the entire state of Starkware, of the Starkware chain. But if someone wants to, and if someone wants to create a bridge for that ERC 721 token, then they can create a custom contract on mainnet that gets the Merkle proof and uses it to mint the token. And that's in general how bridges work, where one side of the bridge has a bridge contract which locks up tokens, either ERC20 or 721 or even other kinds of tokens. It locks them up, sort of like in a safe, freezes them, and then mints it on the other side with another contract.
Yes, that's a really great point, is that the migration has to be manual, and it's not just going to automatically propagate to mainnet. You have to bring it over to mainnet. Okay, cool. And here also with like optimistic and ZK rollups, like what are the pros and cons? For me, I don't know if I'm that able to answer this. The only thing I can really think of saying is that as with all scaling solutions, there are security considerations you have to think about. And so some optimistic rollups, they are running with only like a single validator. So it's effectively like saying that the entire state of the blockchain is being stored and validated by a single computer. And so, there are a number of, layer twos that have billions of dollars locked in them that are running like this. And so that's like a really important thing to keep in mind, is that, not all layer two scaling solutions today are, that secure. And so, but assuming that a ZK rollup has a public validator network that can validate the state of the network and is not just a single centralized validator, some of the pros and cons here are that, again, there is like a little bit of a lower security profile. But I do think that with ZK rollups, they are able to get very, very close to mainnet security, which is really interesting. And then the other downside is that since they're processing more transactions and there's kind of more data associated with these roots, because when you publish that root, in order to know what's in that root, you have to have all the other data available. So layer 2 data availability is something that's still very necessary, and so that's another problem that I foresee as well, is like layer 2 data availability. So yeah, those are some of the pros and cons that I can think of. Anything else that others can think of?
I guess the main pros and cons, at least my understanding, is that ZK rollups should technically be able to do everything optimistic rollups do, but better, because there's zero knowledge. But the problem is that zero knowledge rollups are a lot harder to create. There's a lot more math, and they're like math heavy, and there's a lot more just pure development, both work and research, that needs to go in order to support like the full EVM, unlike optimistic rollups. So that's why they're taking longer to build and to come out, but they are, I think, strictly better than optimistic rollups in terms of both security, in terms of just security, I guess. For optimistic rollups, you need like monitors to monitor the bridge and see if the transactions are being I guess, committed to mainnet via the Merkle route fairly. But with ZK rollups, you don't need that. You got that out of the box. The ZK rollups are, I think, a lot more similar to the way Merkle trees function. So a good way to explain Merkle trees would be, let's say you have a lot of information, like thousands of transactions or thousands of signatures or whatever, and you want to use that data on a contract. Obviously, you cannot store it directly. You can compress it, so you can think of the Merkle root like a compressed piece of information, so a single hash. You write that to the smart contract, and then you can use the Merkle proof, which is something you calculate from the tree, as a sort of key to prove on chain that some piece of information is indeed inside of that compressed root. And with ZK rollups, the idea is similar, where I don't think there's any kind of anonymity, which I think you mentioned earlier in the past question. It's more about you can prove that some computation happened on chain, so off chain, so that with ZK rollups, the only thing that happens on chain is you have inputs to a program, and you have like a program ID, and you can confirm that those inputs and that program give you that output, but you do not need to run that program on chain. So it's a really similar analogy or similar concept.
Awesome. Yeah. Thank you so much, Yuri. That was a lot of really great information. Okay, great. So, some other questions here that I think we can answer pretty quickly because we got like 5 minutes left. Do I need to learn Solidity? I think the answer is no. But you should understand how to use smart contracts if you're building, applications that use them. And also just learning the basic fundamentals of like how smart contracts work, I think will really help you better use them in your applications. What is the biggest oh shit moment in your career? Does anyone have any cool, funny stories about this?
I do. So I was freelancing for an application around a country's electoral college, and I was working with a database that had no backups of any sort, and I was given access to test some stored procedures on some tables, and accidentally I truncated, which means wiping all of the data from the voters table, which had millions of with hard worked collected information, and yeah, so basically I took the whole site down by accident, and I was well aware that the database had no backups. However, it turned out that that database was only a staging database, and that the production database was not untouched, so we could replicate the data from production to staging again. But it was a very, yeah, I went pale for a few minutes.
That's really funny. And I'm really glad that it worked out well in the end.
Yeah, I am too. I think the moral of the story is if you're having sensitive data in your databases that you cannot easily reproduce, like with an indexer, you should probably have backups. You're gonna need them.
Yes, definitely.
And not to have connection strings of production inside of your development machine.
Agreed.
Amazing. Yeah, those are all really great points. One quick one I wanted to share because this just made me think of it. Yeah, so I was working on the tools team at Xbox, and one of my tasks was to improve the tracing that we had through the code, so we could better debug production errors that were coming from devs. And so as I was adding this tracing logic, all throughout our code base, I was practically touching all the core parts of the code base for the Xbox toolchain and operating system. And I didn't realize that in my tracing code, I had a memory leak. And so I wasn't properly allocating and freeing my memory because this was in C++. And so, I had worked on this, and I put up a pull request. And one of the principal engineers on the team, who I thought really had it out for me, he, of course, took a very scrutinous look at my code. And he sends me a message, and he's like, this doesn't free memory. And I'm like, no way, that's not possible. And then I looked a little harder, and I'm like, oh my God, I almost just nuked the whole code base with my shitty code. And so, I felt very embarrassed, and I made sure to write strenuous tests to make sure that was not the case. So I didn't lose all credibility. So that was a moment where, yeah, I almost just nuked all of the developers using our tools. So that was fun. Okay, cool. Any other fun oh shit stories? Oh shit! All right, I have one more. Early on in my Web3 career, I was working on DAO stack projects, and I was helping a user, deploy a DAO. And so what I did was I used a wallet private key, and I added it to a configuration file for their CLI. And so this is, of course, a very bad thing to do, to actually paste a private key onto your computer and run code over it. And so I'm like, okay, just to make sure, I'm going to use a test account, not my main account. I'm going to use a test account. And so thank God I did that, because after I, set up their DAO for them and I ran the scripts, I accidentally committed my private key. And as soon as I did that, there are people that run bots that actually look through all GitHub commits on GitHub, and they look for private keys. And when they find them, they drain the account. And so I was wondering why this test account had all of its ETH drained. And I realized, oh my God, I committed that to GitHub, and it was immediately drained. And if I put any other funds in there, it was just going to get drained right away as well. So yeah, using private keys, always use a test account, always use a development account. And for each new task you do, use a different development account. Because you don't ever want to compromise the deployments that you previously made. Maybe you have an admin key or something like that. But yeah, private key security is really, really important. So we're at the 30-minute mark. And, I'm curious, if anyone has to leave, feel free. If there's any last thoughts that anyone wants to add before they go, feel free. But we could also just finish out these questions, because there's only a few more that we haven't answered yet. What do you all think?
I agree.
All right, cool. So yeah, if anyone has to go, sweet. Yeah, if anyone has to go, feel free. And now is your time to say something. But if not, we'll just continue forward. When did you say Web3 was going to be your job? Who would like to take this one? I know that for me, I had always wanted to work on Web3. And, I saw a hackathon happening and I'm like, okay, great. This is my chance to start to get my feet wet and maybe leave my full-time job. And after doing the hackathon and after winning some prizes, that was when I, was like, okay, like this is really cool. There's opportunity in this. And for the past year, I've already been saving up my money so that I could leave my full-time job. So, I'm financially able to take a risk, and I want to take a risk. And luckily, with Web3 now, it's not as big of a risk because there's tons of opportunities to make money and work for great projects. So, yeah, for me, it was when I saw the viability of it, and also how fun and cool it was after doing a hackathon.
In my case, I didn't find Web3. Web3 found me. And from an outsider's perspective of someone like me at the time, I actually thought that the whole DAO voting to get paid thing was a very sophisticated form of scamming, and I really didn't believe that it would work at first. But after it worked for after I experienced it for the first time at dOrg, and I don't mean after my first client payment, I mean right after my activation challenge, I was like, oh, okay, so this might be interesting, because if this actually works, this is a model that can be replicated across different spaces and it would be really useful to empower communities. So if that's the case, then I would have a high sense of motivation on building tools that would empower other people as dOrg empowered me. That's what I'd say.
Yes, dOrg is a pyramid scheme.
Yeah. So when Caesar first told me about it, and he was like, no, but people have to vote and peer review your code for you to get paid. I was like, oh, okay. So that's how the scam works. So I do some client work for them, and then they're just gonna vote and reject my proposal. Now, good. Yeah, But no, it doesn't work that way.
Amazing. Okay, cool. So then, I'm not a technical user. How much code should I learn? In my opinion, I think that learning a little bit of code in any language would be sufficient, just so that you understand kind of the general idea behind programming. Just doing a quick little course on Udemy or any of the other online courses. I think that can really help you understand code to a level in which you'll be able to, hopefully help project manage on technical projects or speak to more technical people and understand what they're talking about. And the last thing that I would say is that programmers are always learning. And so people that do not code, that work with programmers, should always be learning as well. And so if you have questions about how things are working or like what different words mean, it's perfectly okay to ask those questions. It's perfectly okay. So yeah, always ask questions and learn a little bit of code would be my suggestions. All right, cool. So how does one be a good tech lead? Does anyone want to say this or talk about it and give advice? Yes.
Yeah, so I can say that for what I have learned so far, you need two key things. The first one is patience, right? And the second one, it's like you need to be able to explain yourself, because I mean, this is like being a leader as it is. Because yeah, if you know too much and you don't know how to explain it, you don't know anything at all, right? Like it's hard. So yeah, what I would say is that yeah, after like getting really good at technical things and skills, and for example, yeah, be comfortable with the being the liver and prex and being the leader of it. I would say that patience is the first one, because working with another ones, I have seen this from both point of views, being the one that's being thought and being the one that it's like giving the lesson. And but yeah, like both parts need to be to have patience, because yeah, you will have like some conversations, and you will need to be really try to explain yourself. You need to be like didactic, I would say. That's what's come to my mind when tech lead when tech lead comes. So yeah, I would say so. Yeah.
The biggest trait that I would highlight is probably that you care for the project's code holistically, because it's very easy to fall into the mindset of, okay, so I'll handle like these components or this part of the library, and that's it. Like whatever happens outside of my domain um, is something that I am not interested in. So I think that when you're the tech lead of a project, I don't think that ownership is the best word, but probably like you should care about the different areas of the project and make sure that things fit well within each other, if that makes sense.
Yeah, I agree with everything. And I think that maybe responsibility is a better word than ownership. If you're
Right.
responsible for something, you will help others, contribute to it. You'll help others build alongside you. But at the end of the day, like you view their work as a part of this mission that you are responsible for, and so you take personal responsibility for making sure that it's high quality.
Oh,
Yeah.
and sorry, and one last thing. It's completely possible to be constructive about things that need to be changed, even if there's a lot to be changed, because it's when you have the responsibility of something that you're not doing alone, but you're doing collectively with the team. um I think that in general you should be patient and understanding, because I've worked in the past before dOrg with tech leads that were very like had this mentality of being um, high and mighty, like I don't make mistakes. You are usually the ones who make the mistakes. So like that bad attitude. Um, so actually using the responsibility you have to be constructive instead of authoritative, I think it's also a very good trait.
Yeah, and kind of the last thing that I would want to add here is that I think that it's totally possible to be an amazing developer, but not necessarily want to lead a project, because leading a project requires a lot of interpersonal skills that maybe you do not feel like you are the best to do. And so you can be an all-star developer and have somebody that you work with who is kind of like the team lead that you trust. But if you ever feel like, oh, that this person doesn't know what they're talking about, they're, leading the team in the wrong direction. If you start to have those feelings, either as a seasoned developer or like a newer developer, I think that like programming leadership should always be emergent. Since we're building, technical things, we should always try to have the most well-informed voices leading the pack. And so if you feel like the people leading the pack are not the most well-informed, feel free to speak up and start to actually exercise your own technical leadership skills. This for me was how I did it. I found myself when I worked at a big corporation being led by developers that I did not feel, knew what was best. But yet they were older than me, and so they had that leadership position. And so, they didn't necessarily like me too much because I was very vocal, and I would, try to help steer the team in the right direction. And what ended up happening with that project was I became one of the 2 leaders from the team, really leading the project, and it was an amazing experience for myself growth-wise, where I realized that I could actually lead a technical project at a like higher level and capacity. So like being able to grow into it and always, like practicing your skills of leadership, I think is really important. And it's all about trying to work as well as you can with others. And if you work so well with others that you can now help others work well with others, I think that that's when you know that you'll be a good tech lead. Yeah. Okay, great. So what are the important topics you guys think that any Solidity dev should know, at least to start, about Solidity code in a professional way? So I think that this is like a whole topic in and of itself, but there are lots of great things that have already been done to cover these. So, when working in Solidity, you need to understand that you're, building contracts that could potentially hold tons of innocent people's funds. It's like your code can affect people's livelihood. And so that has to be taken very seriously. And I would recommend, checking out Open Zeppelin. They have lots of really great education on how to write great Solidity code, as well as there are some talks that were given in, I think, like the kernel group, where it was all around security best practices. And I think that a really good one was one that Sam CZ Sun gave. He's a very prolific, or rather should I say they are a very prolific anonymous like hacker that has, stopped a ton of exploits from happening, as well as they created a lot of really great informational material online for how to write better, more secure smart contracts. So trying to look to find the best white hat hackers in the Solidity space and following what they do, I think can really help. But any other thoughts on Solidity code in a professional way? Cool. And I guess that the last thing I would add here is that, you should always start building small. And so if you're being told to work on a project that is a new lending market and you yourself may not feel comfortable building a lending protocol, with Ethereum, it's okay to say, no, I cannot do that. Like that is the responsible thing to say. And additionally, if your code is not going to be audited, you should, I think, in my opinion, you should hold the code from the client if you're working for a client, because it is again a part of your responsibility to not put users at risk. And so if a client just wants to ship something and they want to launch it right away and they want to put user funds at risk for their own personal gain, I think that we as developers have a responsibility to say, no, that is not okay. Like we should take smart contract code very seriously. And there are lots of ways to gradually grow into writing really great smart contract code by, starting small, doing audits, learning from the audits, et cetera, et cetera. Okay, so this is the last bullet point here. What is EWASM and how it can not change smart contract development in an Ethereum ecosystem? Okay, so how it can or cannot change smart contract development. So in short, EWASM is to try and use the WebAssembly bytecode for running smart contracts. Because currently smart contracts are run in the Ethereum virtual machine bytecode, EVM. And so EVM is it's a more unique bytecode, and it's not as widely used. And additionally, it's not as optimized as WebAssembly. So since WebAssembly is so widely used, it's been optimized over time for being able to run it very quickly. And so there's an example actually. If you look at Turbo WASM Arbitrum. They did some really great work. So Arbitrum did some really great work on basically converting EVM code to WebAssembly. And they were able to see a ton of speed up improvements on their L2. And so, yeah, how can WebAssembly change the Ethereum space? It can make running smart contracts a lot faster. That's my main thought there. Any other thoughts?
Yeah, so I can add to that beside what you said, Jordan, the main thing is that yeah, you can write Rust and write a smart contract, right? And Rust as language have like different properties like generics, which Solidity doesn't have currently. That's the first thing. The second thing is that it wasn't development was stopped by basically developers from Ethereum to focus on rollups. Basically, the reason of this is that it wasn't development will to take like too much to basically make the Ethereum virtual machine upgradable and compatible with WASM. And basically, what it's want to be, yeah, like what it's aimed to be achieved is that basically the interaction with WASM will happen through the rollups, right? So basically, imagine like an L2 chain that yeah, basically it's compatible with WASM, and then this can like upload the data to the main chain. Yeah, like through this new mechanism they are adding by separating the consensus layer and the execution layer, if that makes sense.
Amazing. Yes. Thank you, Caesar. Those are really great points. Okay, great. So it looks like we reached the end. Thank you so much, everyone, for spending the time to, either attend this call today or watch this after the fact. And again, like this is like the first of many sessions that we'd like to hold. So if you're a member of dOrg and you would like to see more sessions like these, or you have ideas for sessions that you'd like to see, yeah, just feel free to send messages about it in the chat. To either myself or Nestor, or also a big thank you to Clara, who had organized this in the first place. And so I think that sending ideas to her would be a really great next step to try and get more of these to happen. Yeah. Any last things to say, Nestor or anyone?
That since we're all like dOrg members and friends and colleagues, like if at any point like you have anything that you would like to touch upon in more depth, you can definitely like also ping us about a specific thing or whatnot.
Yes, definitely. Talk to your fellow dOrg members. I think all of us are very open to helping and working with each other. Amazing. All right, take care, everyone. Thank you so much for attending. And yeah, hope you all have a wonderful weekend.
Thank you so much. Bye, guys.
Thanks for hosting this.
See you guys.
Bye, guys.
Later. God bless.
Bye.